Major funding was provided by Nebraskans for Public Television. Among the world's mountains and seas, Nebraska is but a tiny grain of sand. Hidden in its landscape is a history that was carved by a series of natural disasters occurring over 5 billion years. Geologic time, locked in layers upon layers, like pages in a book. Each layer forming a foundation for today's landscape. A land that appears peaceful, but beneath the surface, scientists are uncovering a restless prairie.
The earthquake would have had to have been somewhere up in the vicinity of Richter magnitude 7.
It was the natural forces of erosion that created it, and now it's the natural processes of erosion that's taking it down.
Peeling back the layers of time, scientists can uncover Nebraska's natural history. Along the way, finding clues to our own future survival.
Some of the consequences of environmental disasters that we see in the fossil record are quite scary.
Big time drought, these dunes were bare. I think by looking at the past, we have a better understanding of the damage maybe we could do, or even the good we could do in the future.
The land known as Nebraska has survived milestones of extreme change. 300 million years ago, the state would have been perched on the top of a mountain. 100 million years ago would show the region flooded by a great inland ocean with sea creatures and giant reptiles. Over the next millions of years, as the sea level fell and the Rocky Mountains uplifted, water and erosion carved ancient rivers and aquifers. 800,000 years ago, eastern Nebraska may have looked like Antarctica. As the Ice Age drew to a close, much of today's landscape was intact. It left a gift of fertile cropland to the east. To the west, Badlands and the Sandhills, the largest area of sand dunes in the Western Hemisphere. The Sandhills were the last major change recorded in Nebraska's geologic history.
I think it's an awesome site. I think when you first look at it, you say, there isn't anything out here. And yet, when you realize what this represents as far as the accumulation of these sands, the history of the area, an opportunity to capture and transfer water, I don't think we can ever take for granted any piece of topography.
The Sandhills and its groundwater are like a magnet to hydrologist Jim Gecky.
Oh, you want to come up? Many people in the water industry think that water's been undervalued for years. I guess the value of water is best realized when there's a time of shortage.
The High Plains Aquifer, known as the Ogallala, flows beneath Nebraska and extends as far south as Texas. Sand and gravel act as a sponge, storing water below the surface. The thickest part is under the Nebraska Sandhills.
The Ogallala itself is probably 400 or 500 feet thick, and all of that's saturated. 66% of the supply in the High Plains Aquifer is concentrated within Nebraska, and that's a couple thousand times the storage of Lake McConaughey. We've got 2.25 billion acre-feet of water in storage between the grains of sands and silts and gravels that comprise the High Plains Aquifer.
Even with all that water, the sandy dunes above won't allow for the area to be used as cropland. With 13 million acres of grassland, cattle ranching is the dominant business. All aspects of the cattle business are researched at this working Sandhills Ranch, the University of Nebraska's Goodmanson Ranch.
For how many acres?
About 13,000 acres. Yeah.
1,000 acres. That's a plantation in Maine.
Water experts from around the country, representing the likes of the EPA and DuPont Chemical, have come to get a closer look at the water-rich sandhills.
There are a lot of bison bones up here.
Almost looks like a socket of some sort of a leg bone. A lot of history here.
At Birdwood, near Lake McConaughey, nature provides physical evidence that abundant groundwater is often close to the surface in the sandhills.
And if you don't believe that there's water underground, you don't have to drill a well here. The land surface is incised to the point where you see the intersection at the bottom of the valley and the water table. Year-round, it's always like that. And it's not the large artesian springs, it's a seepage face. In much of the sandhills, the groundwater reservoir is full. It supports the flow of streams. It supports wet meadows. And anytime we talk about groundwater and surface water, it's a semantic difference.
Among the groundwater outcrops in the sandhills, perhaps the most revealing are the natural springs.
Oh, there it is. I got it. It's like Old Faithful. It sort of bubbles and
There is a miniature Old Faithful.
Springs, like Little Growler, suspend sand, creating a loose quicksand that periodically boils or bubbles.
We could only get down about 20, 25 feet. I don't know that that's the bottom of it. Let's wander back on up here and take a look at Old Growler.
That is absolutely amazing.
A boiling spring known as Old Growler is one of the largest, and locals say it's been around for 100 years.
You'll go right up to the elbow.
Whoa! Look at that.
Yep, right on the chin, yeah.
That one spasm was probably the most active, sizable spasm I've ever seen here. I mean, that really was. For as far as sustained activity, that was as good as I've ever seen. I hope we got that on film. Oh, right.
Wow.
Geologists are puzzled by the springs. Neither air pressure nor heat cause the boiling, and it's not known if they reach the aquifer below.
That is incredible.
It's part of the thing you think of, and having the reality be so much more than you imagined. It was just to be able to see it and experience and feel it, feel the texture, feel the energy, and also just the setting. I mean, everyone says that groundwater is the lifeblood of the state, but this is where you really get that feeling that it is. That it's a really living thing. Just great. Just a great moment.
Sand weighs a considerable amount per unit volume, and that settles out and forms sort of a plug, like in some geysers, and then the pressure underneath boils up and the sediment spews out, sometimes in gentle boils and sometimes rather dramatically, like we saw a few minutes ago.
There are a lot of questions yet about groundwater that we have not answered that are going to be fun to explore in the future. And we need to explore those if we are to better understand the connection between surface and groundwater.
Lately, specialists are taking a closer look at the human impact on the water supply.
When we talk about a continuum in a water cycle, it's truly what goes around comes around. We had found out that we had minute traces of atrazine in the rain. You're putting atrazine on a soil, and the soil dries out and blows into the atmosphere, maybe carrying minute traces of whatever chemical it is. It's washed out of the atmosphere, and those chemicals come back down on us in the rain. And it's just not acid rain, it can be atrazine and other things. In Nebraska, we're favored by overall very good water quality. And although we should be concerned, I don't think we should be alarmist in it. We need to be very conscious of what the quality is, but I think there needs to be some degree of moderation.
The massive water supply in western Nebraska is unequaled. In fact, most of the state's important geologic formations are to the west. Countless seasons shaped natural wonders as dramatic as Snake River Falls on the Snake River near Valentine. It is the state's largest waterfall. Nearby, along the Niobrara River, Smith Falls was created, where a small spring-fed creek drops 75 feet over a rock ledge to the Niobrara Valley below. As the Ice Age ended, our climate turned warmer and drier. Spruce and birch forests, which once covered the state, could not survive in this warmer climate and was replaced by prairie. But in the cool, wet canyons along the Niobrara River, remnants of the Ice Age forest survived. Protected from winds at the foot of Smith Falls is a colony of a hybrid of quaking aspen, a northern species, and bigtooth aspen, an eastern species. Native Americans named it Nebraska, broad, flat water. A fair description of the Platte River, but the rest of the landscape is hardly flat. In the great North Platte River Valley near the Wyoming border, Scottsbluff National Monument rises nearly 5,000 feet above sea level. Millions of years ago, this area was roughly a flat bed of rock. There were no Chimney Rock or Courthouse and Jail Rock, but as the ancient Platte River carried Rocky Mountain debris eastward, it formed the landscape, including a series of canyons and buttes. Today, the exposed rocks can be 20 to 30 million years old.
There's some real nice prairie right there. You can tell the impacts of geology on the vegetation, erosion, basically. About right there.
Okay.
Jerry Steinauer and Steve Rolfsmeyer are collecting data at Scottsbluff Monument. The prairie has changed since the early 1800s when scientists began to map the monument's landscape. Now, with the aid of modern technology, Jerry and Steve hope to gather information that can be used to restore the damaged prairie.
When you look on these lower slopes, it's just the typical thing you see in disturbance in prairies. You know, it's what we're used to in other parts of Nebraska. You have these downy brome, Japanese brome, smooth brome coming in, Kentucky bluegrass. You know, they're all indicators of disturbance. What we're going to do is one of our vegetation plots, and we use 10 by 10 meter plots. We'll take quantitative data in this plot and define the plant communities.
And 463, 2237
Okay.
meters north.
Jerry and Steve pinpoint their location on the monument by using global positioning satellite technology. Scientists in the future can look at the same plots to see how the prairie changes.
Atriplex. I really like the native vegetation, the wildflowers. Finding some of these neat slopes where the vegetation's pristine, to get kind of a kick out of it, you know, and it's like, oh boy, I wish it all could look like this, and maybe some of the things we can do can kind of bring it back. This is a national monument. It should be a place where people can go and see representative examples of what the landscape really looked like. That's probably the best, in my opinion, reasons for having some of these places preserved is to keep the vegetation like it was.
In addition to recording data, we're recording history so that people in the future will be able to see how things change over time and maybe get an idea of what to expect and how to manage the vegetation to keep it as close to its original pristine condition.
It was the natural forces of erosion that created it, and now it's the natural processes of erosion that's taking it down. In our standpoint, we might think it's a bad thing, but bear in mind that nothing here lasts forever.
With the help of technology, the native prairie can return to its natural state. But science can't stop the power of Mother Nature. Not far from the Scottsbluff Monument, geologic time may be catching up with Chimney Rock.
Lightning does figure into it. In '92, it got hit, 4.5 foot come off, and lightning does hit it from time to time. But bear in mind, it being sandstone, it's always eroding from year to year. It's just from year to year you may not notice the changes, but in dramatic sorts of experiences like with the lightning, you do notice sizable changes.
Since pioneer days, 50 feet of the volcanic ash and sandstone have disappeared from the peak.
One idea is that we should take a whole gob of cement and restore it to its original height. That would, of course, be tricky. Another idea, actually done by one of the people using our drawing board at the visitor center, involved putting a big umbrella over the structure. And that would, of course, be quite interesting, but not necessarily workable. The name itself starts to come into play fairly early in 1823. Someone referred to it as Chimney Rock or the Chimney. Other things that it's been called is the Nose Mountain or the Nose Peak. The Indian culture here had their own names for it, and sometimes it's difficult to be polite, but bear in mind that people living on the plains may not have had access or experience with chimneys, and at least by local Indians, it was referred to as Elk Penis.
It is the most famous landmark on the Oregon Trail. Chimney Rock was mentioned in 95% of pioneer diaries.
For me, Chimney Rock is a symbol of the West itself, and also the people that were traveling this route a century and a half ago. It was a symbol of the West. It was a symbol of things to come.
Traveling to the far northwest corner of Nebraska, early explorers found a dry, rugged land, too barren to sustain life. Today, it is a good illustration of Toadstool Park, a secluded 800 acres of badlands within the Oglala National Grassland. Toadstool is like a mysterious and desolate companion to the moon.
Apollo 11, this is Houston. You are go for TLI, over. Apollo 11, thank you. Roger out.
Houston, Tranquility Base here. The Eagle has landed.
When Neil Armstrong walked on the moon, his feet were imprinted in a thick layer of volcanic dust millions of years old. The volcanic landscape mimics the alien shapes at Toadstool.
Volcanic ash was ejected into the atmosphere, and then the wind carried it to this area to the east where it was deposited much like dust. And it mixed with the other sediments. And so the rocks around us are anywhere from 30 to 50% volcanic ash that was brought by winds from the west and deposited in this area.
Geologists are finding that Toadstool Park wasn't always the dry and barren land it is today. Millions of years ago, it was a living world with abundant animal life and a waterway, much like the Platte River is today.
In between this, the wet environments and the very dry environments, is the formation in which these trackways were produced. What we're looking at is a runway of rhinoceroses that lived in this area between 31 and 33 million years ago.
can see that it's three-toed, and this happens to be what we feel is a track of a Heracodont, which is a small rhino. It shows that the Heracodonts wanted to get across this river system. They're more interested in moving right along so that they're not basically lunched to anybody and getting eaten by the saber-toothed cats that were around at the time. As you follow the tracks along, the subheracodonts are paralleling the stream and they're walking along. And as you walk across this and you're following those tracks, they must lead somewhere. And they do. They walk right along this ridge and they follow along here until you get to this erosional feature of this canyon. And the actual erosion of this canyon undercuts the actual trackway slabs themselves, and they fall down. So it's kind of one of those stories that, to our knowledge, for this age of material, isn't preserved anywhere else in the world.
Since we're looking at a mud flat, the mud only stays soft a matter of days. If we're being really generous, we have 2 weeks here. So all these animals that left the tracks had to go through within that period. And if something smaller, lighter, had crossed this very soft bed, it would have left a trail. So for right now, this looks like this was the last guy out.
There are a multitude of things at Toadstool that the preservation must have been just like that. Like Dave was saying, these tracks couldn't have been preserved if it wouldn't have been rapid. If it would have been, you know, a slow-forming process, water most likely would have cut all this away. And there's really no guaranteed answer that we can prove right now on why do we have these tracks here. Well, we're not really sure why we have them here. All we do know is that they're here and they really tell a good story.
In the 5 years I've been out here working, I've seen the complete destruction of half a dozen important trackway slabs. Sandstone slabs being damaged from people walking on them, and things like toadstools being toppled. And one of our goals beginning this year is to construct a catalog of various types and kinds of trackways using latex peels.
And it would probably mean that a creature walked across this when it was really wet. And just like the really nice thing about it is that it does very little damage and it gives us a perfect mold of what these tracks really look like. As far as we know,
our latex peels had about 36 hours to dry. Aeration you're coming on earlier. The bird tracks preserved pretty nice.
And from this latex peel, we can then make plaster replicas of it and then paint those, put them in a museum, and you won't know the difference as far as whether you're looking at a piece of rock or a piece of plaster.
To help get a clear picture of the past, geologists need to understand paleontology. The volcanic ash and clay soil mixture has made the area a fertile ground for preserving fossils of extinct mammals.
I'm applying a chemical preservative to the bone at the site. The animal preserved here is a Titanothere. This animal would have stood between 6 and 8 feet at the shoulder, a very massive legs, very large skull with very large teeth that had a pattern on their cusps that indicate to paleontologists that the animal grazed. This site was a vandalized site. Somebody had come onto the national grasslands and illegally excavated one of the vertebrae. 25% of all the sensitive sites we've located over 4 years have been vandalized. If all you're interested in is acquiring an object, you know, to impress your friends, that's okay. Your friends might need impressing. But if you're wanting to work out why mammals at 35 million years ago went extinct at 33 million years ago, because similar environments are being degraded in the modern world, it's very difficult to do that without all the clues you need to conduct your detective work. It's like conducting a murder investigation and then the smoking gun was taken away and hidden. Some of the consequences of environmental disasters that we see in the fossil record are quite scary. Dinosaur extinctions. One theory is that an asteroid hit the Earth, created a dust cloud, dinosaurs went extinct. These theories were used years ago to sort of predict what would happen in case of a nuclear conflict and a similar sort of cloud cover enshrouding the Earth. Would a similar thing happen and most of the current species go extinct, including ourselves? all these things that we learned from the past help prepare us for what these environments might face and how we can sort of influence the outcome in a direction we'd like.
Mysteries are hidden throughout these Oglala grasslands.
10,000 years ago, the area was very different. You know, you can't just walk out onto this hill slope today and kind of squint your eyes. The climate's changed, the vegetation's changed, the landscape itself has changed rather dramatically.
Just a few miles from Toadstool, archaeologists investigate a mysterious death.
We're not here trying to study an instant of what happened in the middle of the summer at 9,500 years ago and get a snapshot of that event. We're trying to understand kind of the whole motion picture that one snapshot frame came out of.
It's supposed to cool off a little tomorrow.
This is the Hudson-Mang bison bone bed. It's the largest Paleo-Indian period bison bone bed in the Americas. And Paleo-Indian is the term we use for the early occupants of the continent, the people over here at the end of the ice ages. These individual bones of the skull are fairly light and soft.
Dr. Larry Todd leads a team of archaeology students from Colorado State University.
You get back into here, into the pelvis, the hind leg, the femur, the tibia, down to the hind toes. So there you've got most of a bison carcass laying there with its head kind of pointing to the southeast.
An entire bison skeleton is by itself an impressive find, but the treasure at Hudson-Mang is the number of animals found.
There can be as many as 500 to 600 complete bison bones per meter square. And what it looks like that we have here is that this is the remnants of a large herd of animals that died as they were fairly closely packed together here. The bison that we're finding at this site are an ancestral form of bison to what we have roaming the plains today.
Exactly how the bison died is the great mystery. The site was first discovered in the 1950s.
The notion was that probably a group of Paleo-Indian hunters came across or were watching a herd of bison, and as they got close to the cliff, do something to frighten them and run them over the edge.
But was there a cliff here 10,000 years ago? Dr. Todd and his crew exposed the buried landscape.
What we've got here in this trench is we've been able to expose in cross-section here kind of a slice of what this part of the hill looked like. And what we can see is that right along here, you can kind of follow that difference between the darker sediments and the lighter sediments above it. And as we continue on up here like this, it begins to slope up, coming up there about like this, and then up into the next trench. It continues on about like this. There's the top of that same soil surface. On up to the next one here, and on up like that. And the initial model of what happened here at the site is that the bison had been run over the edge of the cliff, fallen to the base of it, and died as a result of the fall. Well, what we can see now is that paleosol that we just traced up comes up and it mantles the cliff, something like that. When the animals died, there was a fairly gentle slope back there rather than a cliff. Being able to expose this paleosol has, if anything, kind of added to our mystery of what went on here.
Z 100.618.
You can think of analysis and excavation of a site like this as being a forensic exercise of what killed the bison and what was their last meal like, and you know, on and on and on, your standard detective story stuff. For example, one mandible like this, we can have 4 or 5 different specialists study, and then when we get a group of them, we can start getting a good picture of the herd structure, the environment, the regional range conditions, the degree of tooth wear kind of tells you how much grit there is in the diet, which kind of tells you how much rainfall there was, and so there's a whole series of information that we can get out of there. The bison that we have kind of a whole cross-section of the population, from calves all the way up to real old animals. And the way disease, or many diseases often operate, is the younger animals or the older, weaker animals die first, and the prime age animals live a little longer. So this looks like these animals died fairly quickly, and unless it was an extremely virulent disease that would have knocked them out, you know, within hours of having contracted it all at once, regardless of age or sex or health status, disease seems sort of unlikely. So we've had to kind of reevaluate the whole notion of how the animals died. And I guess the best interpretation we have at present is that the cause of their death is clearly ambiguous, is the phrase I like to use. We're not sure. I kind of like the idea of a grass fire myself that would have swept across the area and sucked out the oxygen, asphyxiated the animals, having them die in place fairly rapidly. But that's a real tough one to evaluate. And that the birthing season, we can assume, was during the spring at that time, as it is now, that this site, the animals died here during the summer. So it throws out all the possibilities of blizzards and, yeah.
The more the general public understands about what we're doing in places like Hudson-Mang, the more exciting the entire search for the American heritage will be. The story of the Americas is easily as rich as anything anywhere else in the world. As an American of mixed heritage, both Indian and European heritage, I'm also coming to grips with the idea that all Americans have been here for a long time now, and it is our heritage. It does belong to all of us in some way.
To help protect the story of Hudson-Mang, plans are being made to build a permanent enclosure.
The actual artifacts, the bones and the points and the little bits of stuff we take out of the ground, aren't the real treasures that we get out of a site like this. The treasures we get are what the environment was like and what people may have been doing and what the bison may have been doing and what the rangelands were doing. I see a site like this as being a gold mine of information sets of a whole variety of sorts.
1,000 years before the mass death at Hudson-Mang, the bison species survived a severe climatic change. At the end of the Ice Age, the Great Plains weather shifted from cool, wet conditions to a climate substantially hotter and drier than we feel today. Most large species could not survive, including the mammoth.
This is the Shafford Mammoth Site. It's west of Stockville, Nebraska, on a tributary of Medicine Creek. This site was found by the Shafford family about 40 years ago when this gully was eroding and they began to find pieces of mammoth bone coming out.
Mammoth remains have been found in nearly every county of the state. The southern region is especially rich in mammoth fossils.
This rib came out here about this far and was exposed.
So far, what we have found is the remains of apparently one single adult mammoth. Well, we don't know if it's a male or female at this point. This is one molar tooth from a mammoth, and you can see that these teeth are very large. This is the surface, the grinding surface. These were very efficient for grinding up large quantities of grass, and mammoths would eat hundreds of pounds of grass every day. The two largest mammoths on exhibit in the world that we know of at this time both came from Nebraska. They stand approximately 12 feet tall at the shoulder. Very large creatures. Both of them are probably large males.
Evidence suggests that this mammoth died between 13 to 15,000 years ago. Steve Holen contends that humans fractured the bones to make tools and weapons.
Some of the patterns that would indicate that these limb bones were broken by humans would be this type of fracture that cuts across the long axis of the bone. This indicates that the bone was still fresh when it was broken. We're going to be making a plaster cast to put on this bone so that it will help protect it as it's transported back into the laboratory. By excavating these types of sites, we can possibly learn how long humans have been in this area. People say they think they know how old the human occupation of the New World is, but really, we really don't know at this point. A lot of archaeologists think that humans only came into the New World, say, maybe around 12,000 years ago, just prior to what is known as Clovis culture. The evidence earlier than that is always controversial at this point, and that's why we're very interested in these kind of sites, to attempt to demonstrate, in our opinion, that humans were here much earlier than Clovis culture, and indeed were probably here by at least 25,000 years ago, at the time before the ice sheets moved south. This is a type of spear used by Paleo-Indians and also used by Clovis people who hunted mammoths in this area about 11,000 years ago.
This is a detachable foreshaft, so you could go armed with several of these foreshafts in just one large spear, so you wouldn't have to carry several large spears. So these are like...
Finding Paleo-Indian spears and tools would help Holin prove his theory. Since 1988, archaeologists have been searching for evidence at Medicine Creek.
This is the La Cena Mammoth site. Early on, we began dating the site, and we now know that the mammoth is about 18 to 19,000 years old. And this represents a controversial site because a lot of archaeologists in North America think that the earliest archaeological sites were of the Clovis people about 11,000 years ago, and this site is well dated at 7,000 to 8,000 years before that.
There are hundreds of archaeological sites along Medicine Creek, partly because of the soil. Unlike the acidic soil in eastern Nebraska, this loess preserves fossils well.
Loess is a very fine-grained silt. It's a wind-deposited fine silt that was probably blown up out of the river valleys and possibly from as far away as the Nebraska Sandhills to this location. It was deposited during the last glacial period between 21,000 and about 11,000 years ago. In fact, this bank behind us represents the full sequence of that loess deposition, and we have the radiocarbon dates from the base to the top showing the time period when this loess was deposited.
In the upper layers of soil are the remains of more recent inhabitants of Medicine Creek.
We've also been pulling up pottery as well.
Archaeological students from Kansas are helping put together the history of the Upper Republican area. They're continuing excavations from the 1940s that found houses of ancestral Indians.
The ones that they excavated are now off in the lake there. Reportedly, there is another house here, and as I say, you can see it. What they basically were was the remains of structures that were built between about AD 1100 and 1300, somewhere in there. And you know, they were small houses. It'll be lighter colored soil in which there's intruded posts that would have been set in the ground to form the superstructure of the house. A central fire hearth that would have ash and the like in it, and then pits that were used for storage and for later disposal of trash, all of which would produce a large number of really good artifacts of tools, pottery, food remains, you name it, they're probably in those pits. So that's what we're looking for here. This is clearly a house that is eroding, and it is definitely worth salvaging that kind of information before it goes into the lake, which it will within the next few years.
It looks like it's going to turn into a pretty large piece of mammoth bone. And when every time we go out, it's a gamble. I mean, sometimes you see bone coming out of the bank. Well, at least there's something there. You have something to go on. To understand archaeological sites, you really need to understand geological processes, how the sites were buried, why they're buried as deep as they are, and what geological processes have affected the site over however many years it's been since they were buried. It's always the new discovery that you hope to make that keeps you going on to the next site and hoping you're going to find something that's very interesting.
If it weren't for reservoirs and landfills in the Great Plains, we would have nothing to look at. We look at lake faces like this, wave-cut faces, yeah. Without those, we'd be really in big trouble. It's going to give us a fresh face to sample. We've been working on
Bill Johnson has uncovered many remains of mammoths and other glacial period fossils. Recently, he made an interesting discovery along the Republican River.
We're located on Bone Cove, which is one of these many inlets that's flooded by Harlan Lake. This face is unusual in that it's the first time in the mid-continent that I've ever been able to find a fault. In other words, where there's a break in the material and there's been movement along that break. And we know how much the fault moved by comparing this buried soil. This is an old soil right up in here. This break occurred right here and slid this side down to here. So we've got this right about here correlating with right up here.
If this was caused by a true earthquake, then the amount of displacement is such that the earthquake would have had to have been somewhere up in the vicinity of Richter magnitude 7. You saw what a Richter magnitude 7 did in Kobe in Japan in January of '95. A magnitude 7 here would clearly be felt in Denver. It would clearly be felt in Kansas City, Omaha, places like that.
No major earthquake has ever been recorded in Nebraska, but that doesn't mean the Great Plains is immune.
There's a fault line that runs roughly from Omaha down through Kansas, down through the Manhattan area, and on down roughly to Oklahoma City, and it's called the Humboldt Fault Zone. And it's had earthquakes up in the Richter magnitude 5 to 5.5 range. If we can establish that this was caused by an earthquake, it's significant in terms of earthquake risk throughout the mid-continent, not just here in Harlan County or south central Nebraska. Geology doesn't stop at political boundaries, and so it's a very natural thing for us to move across state borders from time to time.
Natural disasters don't stop at borders either. The Republican River flows along the Nebraska-Kansas border. 60 years ago, it flooded, killing 100 people. By 1952, Harlan County Dam was in place, taming the river.
I don't think that the idea of a Richter magnitude 7 has probably been factored in out here. Critical structures like dams and power plants and that sort of thing could be affected by a Richter magnitude 7.
I got that.
The fault line's origin may be discovered through seismologic tests.
Okay, fire.
What we do is fire an 8-gauge shotgun shell underground, and that gives us a source of sound energy that goes into the ground. Then geologic layers in the subsurface serve to echo the energy back, and we pick the energy back up then at the surface with these things called geophones, which are essentially a low-frequency microphone. We're seeing echoes from 500 to 2,000 feet below the surface, and so those echoes that we're getting off the units in the subsurface will be able to tell us whether there's a fault which may be related to old earthquakes. In terms of data quality, it's excellent. In terms of what we're going to be able to say about the structure, it's a little bit early to tell yet, but if there's one of these old faults that's not active now but was active in the last 20,000 years, there's likely to be others. We don't know when the last one occurred for sure. We don't know when the next one will be. What we do know is that every day we're one day closer to the next one.
Our cities and dams may not have been built in the same locations with the information that geologists have today.
The traditional way of doing geology is you would go out banging on rocks and only have a limited view of what you're looking at. We saw some geological structures that have never been mapped before down in southern Mexico. One of them is an old ancient fault line with a dam right on top of it. When they built that dam, they didn't know there was a fault there because they couldn't have a regional view. That's what the satellite data gives you.
At NASA's Jet Propulsion Laboratory in Pasadena, California, scientists have developed a technique that transforms raw satellite data into an active three-dimensional landscape.
We're here to learn a little bit more about the kind of work that they do so that we can transfer that back to the University of Nebraska and do this kind of work ourselves. This is a wireframe view of the Omaha scene that we're working on. It's useful for defining what we can see, the terrain we can see, and the general idea of where we're going within the final rendition. This lets you see things that you can't normally see just by looking at a bunch of numbers, looking at just raw data.
This is the northern half of Omaha. This is the Missouri River here that we're flying up. Here's Epley Field, and then the northern part of Omaha and the bluffs. One of the goals of this project is to make this technology available to school children. Instead of getting a two-dimensional picture out of a magazine or a textbook, they get a three-dimensional view of what the places are they visit. Not only on Earth, but they can visit outer space planets too.
What I've got here is a satellite image of the sandhills of Nebraska. And what I'm doing here is defining a flight path that, as we're flying over, we'll be able to see in three dimensions what the sandhills look like. The students that are living in the Omaha-Lincoln area probably haven't all traveled out to the sandhills or have seen it before. So this is a neat way for them not to have to leave the classroom and get a good idea of what that area looks like. This is the Crescent Lake National Wildlife Refuge. It's a very desert-like, and at the same time, it kind of has a wetland ecosystem in the valleys. So what this helps us do in three dimensions is see where the cutoffs are between these lusher lower valleys and the dune tops or the drier upland areas. The Sandhills is a region it's prone to environmental damage, and it loses its stabilized state. So by using satellite imagery, you can see possibly pockets of trouble, so to speak. Remote sensing, by definition, is being able to study something without touching it.
Ready for 2. Scanning on 2.
Due to the remoteness of the Sandhills, scientists created a replica of a Crescent Lake ecosystem near the University of Nebraska at Lincoln. Researchers are watching the Sandhills wetlands for potential environmental damage.
Each plot has a single type of vegetation that is found commonly in wetlands in this area, and we're collecting spectral information off of each canopy. One of the sensors that's feeding us data is pointing up at the sky, and it's measuring the amount of incoming energy to the plant canopy. And then the other is pointing into the canopy, and it is measuring basically all of the energy that's reflected back out, or the energy that's not being used by the plants.
The species that we have growing here at Meade are species that are common to the Sandhills. If you look at wetlands, I think the number is 6% worldwide in terms of total land area. Now, the reason we're interested in those wetlands is because they are a part of the greenhouse gas scenario. They produce carbon dioxide. The marshes are or have been implicated in the production of methane, and both of these are trace gases. That is, they are a part of the global warming equation. The way this works is that they are very efficient absorbers of solar radiation. So, for example, the more methane you have in the atmosphere, the more heating you have. But these are important ecosystems because they do assist us with things like flood control and water purification and the habitat consideration.
To many, the Sandhills landscape is a symbol of the Great Plains' stability.
People had thought that they'd answered everything. This was pretty simple. If the sands came in 20 or 40,000 years ago and formed the dunes, that was it.
But to geologist Jim Swinehart, hidden beneath the landscape is evidence of a restless prairie.
I think that it's such an incredible landscape. It changes so much. I was doing other things, but I kept coming back to the Sandhills. It was kind of like a magnet, you know, drawing you back. It is a unique place in the United States. This sort of paradox between the dry dunes and these wet meadows. This is a swamp. It's perennially wet. The bulk of all the peat known in Nebraska occurs in the Sandhills and mostly in Cherry County. Peat only forms where oxygen is not available to essentially oxidize or burn the plant. So in an area that's continually wet, you can start to build up organic matter. Now it's got to stay wet for a long time. If it dries out at all, then it decomposes.
Swinehart and crew have taken a core sample from 20 feet below the surface.
And then the peat down at this end, it's no longer really peat. It's been degraded to this greasy black muck.
Between the layers of black muck, sandy subsoils are locked in time, leaving behind a warning.
This is definitely sandy, and there's peat on either side of it. We got dates right below the sand of around 900 years ago. And that ties in with work in other parts of the United States, particularly the West Coast, that says somewhere right around 900 years ago, for a couple hundred years, was fairly major droughts throughout the central and western U.S. So we think this is recording a significant period of diminished rainfall in the last 1,000 years. Big time drought. These dunes were bare. It was dune buggy time out here.
The earth is not the good earth to man without rain. Rain for the earth, rain to bring up the falling water table, rain to make crops grow, rain for the grass that ties the earth into place. When the wind clouds gather, nothing holds down the soil.
How severe a period of drought does it take to destabilize this landscape? In the 30s, the droughts of the 30s, which is the most severe that we've had in the last 100 years, the 30s drought of 5 to 6 years wasn't enough. Again, in the spring, that grass will be gone. That'll just be, and all the sides will be nice and wind-whipped.
Blowouts are a common sight in the sandhills. To Swinehart, they are a sign that the sand dunes are slowly moving.
There's too much wind, there's too much sand, and there's not enough grass a lot of the times. So, bingo, you get this scene here. You need 3 things to have dune sands move. You gotta have sand available, you gotta have wind, and you have to have mostly an absence of vegetation. Because sand only moves by bouncing. Just get rid of some of this vegetation and we'll have a great sand sea. Geologists can come from far and wide to study active sand dunes. We wouldn't be raising much cattle. So, given that, we'll go for the cattle. We got plenty of other sand dunes around. Smells earthy. If we hit a drought like it looks like happened maybe 800 or 1,000 years ago, that might have lasted for 100 years, no amount of good range management is going to protect you from losing all your grass. These dunes will definitely become active again, but I don't know if that's within 50 years or 500 years or 2,000.
The Sandhills drought record proves that the Earth's climate can change dramatically over time. Drought may not happen in an instant like an earthquake or volcano, but it can be just as devastating.
By looking at the past, we can get an idea of how rapid this system of dunes and wet meadows and prairie grasses, how fast that could change on its own terms without humans throwing in their 2 cents worth.
We're finding out that Nebraska is a very, very dynamic place. And you can look at that out here and say there isn't much there, and you ignore universes within that. There's just a lot of complexity out there, and it ties to everything.
Science is a slow process. It takes hundreds of people, hundreds of years to accumulate the information, but then the insights gained from that help us manage our rainforests, our savannas, our prairies, our woodlands.
When I took my first geology course, I realized that every time you break a rock open, you're seeing something that no one has ever seen before.
All these things that we learned from the past help prepare us for what these environments might face and how we can sort of influence the outcome in a direction we'd like.
Our future generations are going to be very unhappy with us if we haven't done all we could do. And there's nothing like the present to do something.